necessity of bioenergy management and bioeconomy, potential of biomass. We have first generation biofuels, second generation biofuels, and then we have third generation of biofuels. And then I am going to discuss about the different technologies which are available. Some of them are mature, some of them are still to be matured. And gentlemen, there is a great role for knowledge management, knowledge creation, and human resource management in this area. Well, you know that ever increasing oil prices, that is beyond US dollar 145 per barrel, and the continuous depletion of oil resources has compelled the world to think seriously about the national energy securities. With increase in the rate of consumption of oil due to population explosion and demands for energy, oil reserves of the world may not last for more than 40 to 50 years at the present rate of consumption, and we have very legal oil reserves in India. Demand of coal is also increasing, and the coal reserves may also not last for more than 200 to 50 years at the present rate of consumption. Well, we also know that there is a lot of CO2 emission caused by the combustion of the fossil fuel, and there is an increasing thrust on biosequestration of CO2 by growing more trees to arrest the ill effects of the global warming. So there is a fuel farming by growing the faster growing trees such as poplar, or there is a thrust on short rotation forestry, which are the common examples. Woody biomass supplies about 80 to 90% of energy needs in some of the underdeveloped countries. And biomass, as all of you know, is a renewable source of energy through photosynthesis. The fossil fuels such as oil and natural gas, they supply not only fuels, but they are also feedstocks for chemical, petrochemical, fertilizer, and pharmaceutical industries. Well, you see, this role of petroleum and the coal cannot be replaced by solar, wind, or other renewable energy sources, and for this, biofuels are very important. Biomass is very important. Biomass can be converted to oil, gas, and other non-polluting solid fuels, which can substitute the role played by fossil fuel. The current availability of biomass in India is estimated at about 500 million metric tons per year as per the MNRE. Studies have been sponsored by MNRE, and there is surplus biomass availability of 120 to 150 million tons per annum. That is about the agriculture and forestry residues, and that constitutes around 18,000 megawatt of potential. Well, you see, these data are a bit varied, and this has to be just taken with a pinch of salt. But the main thing is that biomass is available and is an energy source, an important source of energy. Biomass does not contain sulfur, and it doesn't contain much ash, so it's better than the fossil fuels. Proper planning and management of biomass sources is required to increase its availability, and sources such as animal dung, night soil, agro residues, forest waste, rural, urban, and industrial waste, and biomass from dedicated crops can be utilized. In the morning, I was reading miscanthus is an important grass, which US and other countries are thinking about using. Well, you see there are the projection of MNRE, which says that there is a huge potential for biomass power, agro residues, and biofuel plantation, and there is around more than 16,000 megawatt, and only around 1,000 megawatt which has been tapped. And then there is a biogas cogeneration around 5,000 megawatt, and so far we have tapped only 1,854 megawatts. Next. Well, you see, what are the sources of biomass energy? Biomass energy can come from ocean and freshwater habitats as well as from land. Possible future energy sources such as hydrogen or fossil fuel cells would also be considered as biofuels, and these will have a different series of technical challenges than those for current biomass energy derived from industrial plants. And there are issues about the yield of hydrogen and the hydrogen generation technologies. Nuclear and hydroelectric power are other two large sources of non-fossil fuel energy, each contributing as much energy as biomass contributes. Renewables such as wind and solar currently sum to less than 12% of global energy demand, which may increase to 60% by 2070. So there is a great potential for bioenergy in future. And there are some advantages of biofuels, and these are as follows. Biofuels represent a CO2 cycle in combustion. Most of them have better emissions, and they are biodegradable and contribute to sustainability. Biofuels have considerable environment-friendly potential. In North America, policies that have grain-based ethanol, example, they compete in the market. These were extended, and additional policies to increase biodiesel utilization are being discussed. These are the first generation fuels. They wanted to exploit the starch for getting the bioethanol. And in Europe, there are guidelines to ensure motor fuels that contain certain levels of alternate fuels have been established, and biofuels are expected to be primary way these fuels are made. In South America, Brazil also continued policies that mandate at least 22% ethanol in engine fuels and encourage the use of vehicles that use hydrous ethanol to replace gasoline. Now, these are the second generation biofuel. In the worldwide, production of biodiesel has increased in the past decade from 242 million gallons to 4.7 billion gallons in 2009. There's the report, contribution of renewable energy in power generation in the world may increase from 2.5% in 2007 to 8.6% by 2030. What are the biomass conversion options? The availability of biomass may be one of the major issues in planning any strategies for biomass utilization. However, production of biomass by photosynthesis is one of the best options for biosequestration of CO2. Assuming that with the advancement of research in agriculture, botany, physiology, photosynthesis, genetic engineering, tissue culture, and other biotechnological approaches, plenty of biomass can be made available on the land or as an aquatic biomass, then there is a need to select some suitable technologies. So there are three options. These are chemical conversion, thermochemical conversion, and biochemical conversion. Well, that's a chart which normally I show to my student how we can directly utilize biomass, or we can use it as a briquetted fuel, or we can pyrolyze this and use it, or we can gasify this. We can use the gaseous fuel. We can clean those. We can get hydrogen. We can do the hydrogenation of biomass to get liquid fuels. Or there is a technique we can do hydrolysis, we can get ethanol, and we can get biogas from the biomass. There are different biomass conversion processes to get biofuels. Biofuels are liquid or gaseous fuels made from plant matter and require and the residues such as agricultural crops, municipal waste, and agricultural and forestry byproducts. Anaerobic digestion of biomass has been practiced for long and is very popular in many developing countries such as China and India. The organic fraction of almost any form of biomass can be broken down through anaerobic digestion into methane and carbon dioxide, that is biogas. The potential of ethanol production from wood and other lignocellulosic is need for management